Afternoon, everybody. Dear friends, you can use your chat box and you can use some icons like thumbs up and claps. Make use of it. Nobody wants to use? Okay. Because there is no interaction, just we are doing chart. Sir, can you unmute all? No, time waste.
No. If you want me to do it, I'll do it. That's not a
No,
problem.
nothing. Okay. Okay, dear friends, I would like to give a simple tip in chemistry. No, not chemistry, in real life situation. See, we don't know how to use our brain. The problem is whenever you go for a new instrument or when you purchase any article, you will get a leaf out about the description of whether it is cell phone or refrigerator or airplane, whatever it may be, you will get a description. But there is no such description to use how to use brain. That is the problem. So there are simple tricks. Our brain is very tricky. We can say our brain is a monkey. If you know how to play with your brain, you can play with memory. When you can play with memory, you are a genius. So for this, there are certain techniques which we cannot deal. Just I will give certain tricks. In future course, we are going to have, especially how to use brain in chemistry, we are going to have a course. I will tell you one thing. Memory is related with observation and repetition. Observation is mother and repetition is memory. You are having that memory can be converted into psychomotor domain. When you are using your body parts and coordinated with brain, you are a skilled person. I will tell you one thing. You remember that my birthday is on 23rd October. I am arranging a party at 6 o'clock. I invite you all. All types of dishes will be available for you. Okay. But the problem is the place will be decided later and I will inform you after some time. Anybody? You can type in the chat box. This indicates that you are not listening to me. I am again repeating. See, my birthday is on 23rd October. I am arranging a party at 6 o'clock. I think now you are Busi.
Sir.
Is it audible?
Yes, sir. Is it audible? Audible, sir. It is audible.
Okay. So when I am saying this, nobody is responding, but hope you are listening to me. You say to yourself, my birthday. When is my birthday? 23rd October. When is the party? What is the party time? At 6 o'clock. You should remember, because I am going to give a non-veg party. You should remember this. You will have a great time. The brain will remember this information because you are having some refreshment there. Now let us convert this information into a logical thing. 6 o'clock is the time. October is 10th. And the date of the party is 23rd. So 6 into 10 to the power of 23 is a mole. It is Avogadro's number. You can cheat your brain and you can remember the information and you can convert the same information into a logical number. My birthday is not on 23rd. Okay, just I am kidding you, because to remember 6 into 10 to the power of 23 Avogadro's number, you can remember 23rd October at 6 o'clock party, because our brain will remember nonsense things. This concept is called as keep it simple and stupid. This is KISS concept. Okay, now I hand over to Busi Anil to continue the class. Thank you.
Right, sir. Thank you. Thank you so much. First time, even I have come to know about this KISS technique, but I think it works. It works, because mind has different kinds of ways in which it remembers the data. It is not a stupid one, but it is a clever and smart one. Definitely. Okay, right. So I hope I'll just this is the time for me to just get into directly to the topic. Okay, so yesterday, okay, it was just like a what Shukla sir has shared in it is just like a refreshment for you. Okay, so directly, if I get into to the topic, probably your mind might not be in a position to okay mold itself properly to this code. So that's the reason why sir has just given a valuable tip. Probably that that lacked as a very good starting point to sort of our today's class. So yesterday's class we were focusing on different kinds of toolbars. We had 29 toolbars in our ChemDraw application. Toolbar means it is not single tool. A toolbar is a collection of tools. So as per that, we had a different almost 200 to 300 different kinds of tools, in that ChemDraw application, which we try to see, not exactly tried each and every tool in each and every toolbar that is present there. We tried our level best to go through each and every toolbar and all the tools that are present in each and every toolbar. So that's what we have done it in yesterday. So apart from that, what we have done yesterday, that we focused on one special toolbar, that is a general main toolbar, the toolbar that exists and right at on top of the window. Let me show you first of all the ChemDraw application directly. So this is what left side, what you are looking at it. This is nothing. This is the main toolbar. This main toolbar we focused on yesterday, and quickly I went through all the tools that are present in this main toolbar, and I tried to explain it to you. And if you excel in this main toolbar, probably 40 to 50% of every work that you'll do on chemical structures and reaction mechanisms, to draw and to present it, every 40 to 50% of the work you can do by simply using this one single toolbar. That's why this toolbar is called main toolbar out of all the 29 toolbars, because most of the basic tools that are needed to change or modify or to draw chemical structures and mechanisms that are present in it. Actually, if you try to see this main toolbar, how many tools are directly you can observe: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this line 18 and this line 18, total 36. Now, don't think that only 36 tools are present on this toolbar. If you could see, there are under some tools, on the top bottom corner, there are some black colored arrow marks for some tools on this main toolbar. Okay, if you see, this one is also having one bottom corner arrow. This one is also having one bottom corner arrow. Okay, this one is also having one bottom corner arrow. So wherever this bottom corner arrow mark is present, that means that itself is an another toolbar. That itself is an another toolbar. By simply click, okay, you will come to know how many tools are there in that particular toolbar. Okay, if you click that, then automatically another toolbar that appears, in which you will find so many other tools present in it related to that particular tool. So here also double bonds, if you click that bottom arrow, so then you will see plenty of different kinds of double bonds. Just like that, this one is a pen tool, and this one arrows, plenty of different kinds of arrows. That particular tool itself is a another toolbar. Okay, not like only 36 tools are present on the toolbar. That is not the case. You have almost like a some around 70 to 80 tools are present in one single main toolbar. So if you excel in this particular toolbar, then definitely you are just going to be so comfortable with this ChemDraw platform. Okay, I have gone through quickly yesterday. So even if I just try to describe it, individually, you will not learn anything more. But if I take examples and if I try to show you how we can use this main toolbar, probably you will understand it better. Today, so today, as I told you yesterday, that today we are going to focus on the drawing of structures. That is the main thing. Actually, the students who are waiting, okay, who are waiting, to see what is the power of a chemical toolbar. This is the day. The last 2 days, I try to develop a platform of making you comfortable. That so that you will come to know what is the starting point, what is the software from where you have to download it and how to install it and what are the basic menus that are present in the platform. Then after that, yesterday we focused on different kinds of toolbars. That means you have to keep all these tools in your hand, and now you have to go to a place where you can do all these making modifications and selling and all this that you are going to see today. So let me just quickly go through. Okay, what we are going to just do, I'll show you. Today we are going to take a few examples, in fact 6 examples. Okay, all these 6 examples are of different kinds. All these 6 examples, one by one, we will try to draw. We will try to draw in on this ChemDraw platform by using this main toolbar. By using this main toolbar, this class is going to be very essential, very interesting, and it is very essential to all of you who are attending today. That is 94 participants are there. Actually, the number is decreasing, but this is the day where exactly every participant must come and attend, and they have to just learn something out of it. So first example is this one we'll focus on. Second example is this one we'll focus on. Then after that, the third example. Okay, then we'll move on to the fourth example. This is the fourth example. This is the fifth example. This is the sixth example. And if you see properly, and each molecule is of a different kind. This one, if you see a simple molecule, this is a very simple molecule. When it comes to here, this is a cyclic molecule. This is a cyclic molecule. When it comes to here, this is a Fischer projection formula. That these are the structures that we do come across in chemistry quite often. Okay? So when it comes to fourth example, this is just like one of the perspective kind of a model. Okay, this one is a Newman projection kind of a model, and this one is involving a stereochemistry. This is involving a stereochemistry. So all these 6 examples are of different kinds, and all these 6 examples we will try to draw it today, so that slowly I'll try to go example by example and try to focus on each and every example. If we practice all these examples, and I'm sure you will be going to cover that any kind of structure that you can draw, because whatever the tools that we are going to use it today from main toolbar, and the same tools with which you can just create any kind of it doesn't matter how much big the molecule is, you can simply draw that on this platform. Okay, now let me take the first example. Okay, this is example. Let me just okay, so this is the first example, structure 1. We shall see how to draw this one. Okay, carefully observe this molecule. What type of tools are needed to draw this molecule? What type of tools are needed to draw this molecule? If you carefully observe this molecule, here you will see a single bond, and this is a single bond, and this is a double bond, and there is an oxygen. Okay, if you could find out from where I have to borrow single bonds, and from where I have to borrow double bonds, and from where I have to borrow oxygen, if you know this, then automatically you can draw the structure. It's very simple. If you see this general main toolbar, in that main toolbar, the single line that is there in here, and the first column, third tool, and that is the one which gives you an opportunity for you to draw a single bond. Okay, let me click that. Let me select that. Then after that, I will just put. Okay, otherwise just let me put it this way. Okay, so this is what a single bond. Now just carefully observe that, and this is what we have drawn it. Now the second single bond that I need to draw, simply go to one of the corners. Still it is selected, that single bond is selected. By keeping that as a selected, just go to one of the corners, and you try to observe that when I keep on the other corner, there is a circle, blue color highlighter, and at the same time on the other side also, circular blue color highlighter is just coming. The moment I put it, my mouse cursor on it, these are the things that you are observing. When I keep it in the middle of the bond, and there is a cylindrical blue color highlighter is just coming. And what are these things? Tomorrow you are going to come to know about it. because that gives you a lot of edge, or I mean, like to draw quickly the molecules. That I am going to teach you today. Right now, let us focus on how to draw the structure. So you have to take your mouse cursor to one of the ends and just simply click. The moment you click that, and another single bond will come into. So now we have drawn this bottom part of this molecule, bottom part of the molecule. Now we need to draw here a double bond, double bond. So how do we do that? There are different ways in which you can do it. There are different ways in which you can do it. So simply
Anything wrong, Busi? Please wait. I think there is some technical problem with Busi, sir. He will join. Anil, sir? Busi?
Sir, is it audible, sir?
Yeah, yes, yes.
Yes, sir. Yes, sir. I'm running the show on cell phones data charge. Nothing to worry. Meanwhile, if we get the power, then automatically it will get resumed. That's not a problem. Till then, I'll try to
Otherwise,
run the
okay.
show based on that.
Otherwise, we will
No problem, sir.
wind
No
up and we
problem.
will. Okay, sir. Okay.
No problem, sir. Till then, I just try to finish it off. Okay, right. So here we have finished the bottom part of it. Now let us focus on this double bond. So there are different ways. The manually, you can simply go to this double bond on that main toolbar, select the double bond and just come over here, and where you want the double bond, just put it there, that circular blue color, highlighter. So simply just click that, then automatically double bond comes over there. Okay. Now we have finished these bonds. Now we need to put oxygen into it. And how do we put that? It's very simple. Go to the text box. Text box. This is a text tool or text box. Simply select that and just come over here and put the highlight, and try to make sure that just that circular highlighter is there on the right place. Otherwise, what happens, if you just put it in somewhere, and if you draw, put oxygen, type oxygen, and that is not going to look proper. That is not going to look proper. So that is the reason why simply just take that cursor onto the right place and click with your mouse and type oxygen. That means O. So then automatically you'll get that molecule. It's as simple as that. This is as simple as that. Okay. Now we have drawn the molecule of propane 2-one. If you want to give numberings, you can give numberings. That is not a problem. So simply by selecting that molecule, you can move to any place that you want after creating that. Okay, you can put it at any place. And if you want to give numbering, simply go to objects and object settings. Okay, here you can see an option under drawing, that is show atom numbers. Show atom numbers. If you click that, and if you click OK, then automatically you'll get the numbers. Again, I am trying to show you. You need to select the molecule if you want to give the numberings. Simply go to object menu. Then after that, select object settings. Then select object settings. Once you select that, a pop-up window will come in. And after that, you make sure that you are there in the drawing option. So under drawing, you can see at the bottom, show atom numbers. Show atom numbers. Click that, then automatically click OK. You will get the numbers. Okay, it's as simple as that. Okay. For example, if you want to delete manually also, you can delete it. That's not a problem. Numbers. If you don't want this 4 number, you can delete it manually. Okay. Then now, if you want a name of a molecule, simply select the molecule. Simply select the molecule. On the top here, the structure
toolbar is there. Structure. This is what structure toolbar. Here you can see if you have a structure, you can get a name. If you have a name, you can get a structure. These are the two tools with which you can generate a name from a structure, or from a name you can generate a structure. From a structure you can generate a name. Here we have the structure. So by selecting this, if you click, for example, you need a name from a structure to name. Simply click that, then automatically you will get a name. You will get a name. So this is how you get the molecule. Whatever the molecule that you want to draw, you can draw. For example, here we have chosen this molecule. Now, what are the other things that we can do after drawing a molecule? It's very simple. I will tell you, once we draw a molecule, what are the other things that we want to do? Okay, simply select the molecule. Okay, for example, sometimes what we want to do, we want to just attribute colors to bonds, to atoms and all that. Simply, you don't just 1 minute, I'll just put this okay. Now if you want to attribute color to the molecule, simply select the molecule, and you can see this toolbar we call a general toolbar. This is called a general toolbar. At the the end of the toolbar, you can see this colors box. Click that, and you will get different kinds of colors here. Okay, let me just attribute red color to this molecule. Okay, if you click the red color, automatically you will the whole molecule gets turned into a red color. If you really, for example, you don't want all for example, you want this oxygen should be in the black color. Simple, you just select that oxygen molecule, then go to this oxygen atom, just go to this colors box, and you select black color, then automatically it turns out to be black. Okay, if you want to just make this oxygen to be bold, you can make it bold by clicking from using this general toolbar. There is bold option over here, and italic, underline, everything, whatever that you want to do, you can do it here. Okay, so I have turned this oxygen into a black color. Sometimes what happens, we don't want all this. Double bond should be there in the red color, and single one should be there in the black color. Simply select that. Okay, select single bond. Now I'm selecting single bond, and I'll go to the color. Okay, I'll put it as a black, so it turns out to be black. Even same way, just you click that a single bond, and you go to the color, and you attribute a black color. So that's how you can attribute different colors to atoms, bonds, so that the whole thing will be a very colorful one. This is one of the attributions that you can do. Okay, this is very important. I have shown you how to draw the molecule. Then after that, I have shown you how to attribute colors to the molecule. Now, sometimes what happens? Sometimes what happens? You want some of the properties of molecule. Simply, whenever you want something, you try to select the molecule. You simply go to structure. Object. Yes, nice. Okay, we got the power, so it will not get interrupted. Okay, so here you can see view option. Just go to view. Okay, view menu. You just simply go to view menu. Okay, once you go to view menu, then you can see here there are a couple of toolbars are there. Here couple of toolbars are there. One is a show chemical analysis, show analysis window, show chemical properties window, show analysis window, show chemical properties window. Okay, let me click this show analysis window. These two are going to give you extra information of that particular molecule. By selecting that, go to view menu, then select show analysis window, and you will get regarding this particular molecule, propane 2-one. This is the formula, this is the exact mass, this is the molecular weight, this is M by Z, that is mass spectra details, and elemental analysis. This is the data. If you want this data should be there along with this particular name, simply click paste. Okay, then automatically the whole data comes over here. Okay, for example, if you don't want all these data, if you deselect, for example, M by Z, you don't want it. Deselect that, and remaining things, make it as selected. Then just click the paste option. Then automatically the remaining, except this M by Z, rest of the things will come into. Okay, that's how you can choose what are the properties that should appear under this particular molecule. What I'm trying to tell you now is about drawing a single molecule, and attributing a name to it, and attributing colors to each and every parts of it. Then after that, adding an extra chemical information. So for single molecule, I'll show you all of this, and rest of the molecules also we can do the same. In fact, after that, if you practice it with different kinds of molecules also, you can do the same thing. So that's why one by one, I'm trying to just cover these things. Okay, now I have got this data. There are other data also that you can get it for each and every molecule. What is that? By simply selecting this molecule, go to view menu, then select a chemical properties window. Chemical properties window. If you select this chemical properties window, and a properties window like this will appear. Okay, all these are melting point, boiling point, critical temperature. For this molecule, these are the chemical properties of it. If you want to paste all of these, you can simply by clicking this option of paste, all this data will be transported onto this platform. So that, see, after that I'll show you the whole data that you can copy and you can take it to Word, PPT, or any place that you want to. Okay, so whatever the data that you can grab, maximum data, you can grab it and you can put it there. So let me paste it so that the whole data will appear under this molecule. Here you can see the whole data has come. So just imagine what are the for one single chemical, after drawing, how much data that we are getting because of one simple ChemDraw package. Hello, excuse me, there are some people who are just please unmute yourself. There are people who are making noise.
Sir, you carry on, sir. I am unmuting. No problem.
Yes. Okay, right, sir. So this is the ample amount of data regarding a particular chemical that you can just in a fraction of seconds you can get it by simply just with one click. Okay, so is this the only thing that we can get it for a single molecule? No, there are plenty of other things that you can get it. Okay, by selecting this particular molecule, you can go to structure. Under structure, you can see. Under structure, you can see there is a predict proton NMR, predict proton NMR shift, predict carbon 13 NMR shift. So if I click a proton NMR shift, we will get a proton NMR spectrum of that particular molecule. If I click that predict proton NMR shifts, then automatically I'll get the whole NMR spectra of that particular molecule. Okay, let me just do that. So if I click that, then automatically just look at it. This is what the NMR spectra of. There are some people who are making noise.
I will take care, sir. You carry on, sir.
Yes, sir. Yes, sir. Okay, so this is the NMR spectrum. Just imagine. See, within no time, you can get an NMR spectrum of proton NMR spectrum of that particular molecule. Here, just beautiful how beautifully this is. The data is also analyzed here. You can see it's not simply a single spectrum that that will be given. Not only that, there is a lot of analysis also of that particular spectrum that is present. All right, that's what you can do. Okay, that's the most beautiful part of it. Okay, then after that, by selecting that, so if you want a carbon 13, simply go to structure and click carbon 13 NMR. Then automatically you'll get this is a carbon 13. Here you can see Chem NMR carbon 13 estimation. Okay, here you can see there are a couple of peaks are there. Okay, so here this is the analysis part of it. That is how you can get proton NMR and carbon 13 NMR of a particular molecule. This is an ample amount of data that you can get it for a single molecule. Okay, now once you create all of this, okay, once you create, okay, once you sorry, so let me select both. Okay, so this is what the molecule with the data. For example, sometimes what happens, you want to copy this and you want to paste in a Word document, right? This is what we do after creating a particular molecule. And what we want to do, we want to export it to another document. It's very simple. There are different ways in which you can do it. What is that? One manual way is what? Simply right click this by selecting whatever that you want. Simply right click and copy, and simply go to Word document. You need to try to paste it. Simply go to Word document and try to paste it. Otherwise, there is another way also that you can do it. Simply save this document. Okay. Okay, simply save this document. If you say, how to save this document, it's very simple. Go to file menu, and there is an option as save as. Just click that save as button. Then you will be given an option of place it, the place where you want to save it, in the form of which you want to save it. It's very simple. Here by default, you will see save as a ChemDraw. save as ChemDraw file. ChemDraw file means, once you save as ChemDraw file, then automatically you can easily use that file again to do the modifications of it in ChemDraw. Otherwise, there are plenty of other options are also there. If you scroll down, in that save as type, you will find different, here you can see GIF image also you can convert into, and not only that, most of the time, what a JPEG image, here JPEG image. Sometimes what we want to do, not as a ChemDraw file we want to save it, sometimes we want to save it as an image file and we want to send it. So at that particular moment of time, you can save as even this document as a JPEG also. Let me save this. Okay, let me save this under a desktop, on desktop. Proper to own. Okay, so as JPEG I'll try to save on desktop. Okay, save. Here it says that if you save in JPEG form, you cannot later on do the modifications in ChemDraw. That is what the essence of it. Yeah, if we want to do any other changes in future, we will try to save that file as in a ChemDraw file only. If you don't want to change that, and if we want to send that document as a JPEG or image format, to another person, we will try to save it here. Okay, you can say simply okay, that's not a problem. Okay, now you can go to desktop. Otherwise, just I'll show you. I'll show you my computer, this PC. Here I am trying to show you the JPEG image that we have created. So this is what a JPEG image. Here you can see that a propane 2-1 in a photos format. This is what a JPEG. This is how it gets saved, and if you want to send it, you can send it. How beautifully it is saved. Just have a look. Hello. Sir, hello.
I request all the participants to mute themselves kindly, please. Lucy, what happened? Okay, dear friends, there is some technical slang. We will join. Please wait.
Hello. Shukla sir.
Hi, no, welcome, sir.
Yes, sir. So now I just got reconnected. That's not a problem. So let me just share ChemDraw. Okay, now we have finished the first structure. Let us move on to the second structure. Okay, what is this second structure? Simply, let me just take another new document. Okay, in that, let me just take a second structure. So what is the second structure? So this is what the second structure. The second structure is of So this is what the second structure. Let me just put it here so that you could see how to start and how to go about it. So this is a structure that we are going to draw now. Okay, this is a cyclic structure, cycles, it got involved cycles. So let me just take cycles initially. So here you can see this. Okay, here if you closely observe this molecule, there is a benzene ring, and it's not exactly a benzene ring. Second one, it's having a cyclohexane kind of a stuff. Then after that, there is a double bond over here with oxygen. Then after that, this is whole thing is just looking like a cyclopentane. This is exactly looking like a cyclopentane. Now, how to go about it? Is it a good way to start with a single bond, then after that double bond? No, no, no. We have already predefined structures with the benzene and all of that. So let me just take that benzene directly. Okay, let me take that benzene. Now I have just drawn this particular part of it. Just here you can see, easily. Now I want another benzene type of a ring. It's very simple. If you want to draw directly, cyclohexane, you can just select the cyclohexane ring from this main toolbar. Just come over here. Here, actually the cyclohexane ring is to be fused with this benzene ring. So what you need to do is you have to put it on that particular bond where you want to fuse the cyclohexane ring. Simply click that, then automatically you will get that. You will get that ring. Now we have finished this one. So now what we need to do is very simple. Double bond we have to add. Okay, before adding double bond, let me just add this one also. If you try to just take this cyclopentane ring from a main toolbar, okay, so and you try to draw it, and we need to fuse it. So let me just put it here and try to draw it, but this is not the way. This is not coming properly. Let me put it here and just let me do. This is also not coming properly, so that means this is not working. And then how do we need to do? It's very simple. Manually we need to do it. Manually, how do we do that? Simply just take a single bonds, because this is a single bond, this is a single bond, and this is a single bond. So let me just select a solid bond or single bond. Then let me just draw one single bond over here, one single bond over here, one single bond over here. Now I need to add another single bond. It's very simple. Simply draw one single bond from here to here. Now we have drawn even this cycle also. If something is not working, from cycles directly, you can draw manually. That is not a problem. Okay. Now we need to put this double bond. You know that how to put a double bond. Simply go to the double bond and select a double bond and put it here. Select the place where you want to put the double bond. Then select it. Then automatically double bond comes over here. Then after that, you need to put oxygen. For that, what you need to do, you need to make use of text tool. Text tool means this A, letter A is the text tool. Simply select that and put it over here. Then after that, in keyboard, you try to type oxygen or O. Then automatically, if you enter, then automatically it will be there on it. Okay, this is how. Just look at it. Now we got this molecule. Okay, we don't need any other things. So it's very simple. Now, as I told you in the previous example, what you need to, once you get the molecule, you first thing, if you want to attribute a name, simply select the molecule. Select the molecule, and you want a name from this structure. So structure to name. Okay, after selecting it, then you simply click this option from this structure toolbar. This is a structure toolbar. Simply click that, then automatically you will get a name of this. So then after that, if you want to attribute colors, what you need to do, I have told you in the previous example, simply select the molecule. Otherwise, if you don't want the whole molecule to be in one color, simply select whatever the color that you want to change it. For example, this oxygen, if you want to change it to another color like red color, simply go to the general toolbar. This is general toolbar. Simply go to this color option and select that and select red color. Then automatically it will become red in color. If you want to make it bold, this letter, you can make it bold. You just simply by selecting this bold. Okay, it will become a little bold. Okay, if you want to increase the size of a molecule also, you can increase it. It's very simple. Select it. Then after that, you go to the one of the corners. Then automatically the cursor turns out to be an arrow mark. Simply you can increase the size and decrease the size. Increase the size, decrease the size. Increase the size, decrease the size. Just like that, if you want to move this molecule from one place to another place, simply put your cursor in the middle, and automatically you will see a hand kind of symbol, and with which you can just move the molecule from any place, from one place to another place. So you can attribute the colors, and you can just increase and decrease the size of it. You can move from one place to another place. Now, if you want to just give a properties of this particular molecule, simply select that. You go to view menu, where you will see show analysis window. simply click that, then automatically this particular molecules, okay, analysis data comes over here. Then if you simply click the paste button, then automatically this will come over onto this platform. Just like that, if you want to put chemical properties of this molecule, simply make it selected, then you go to view, then click show chemical properties window, and these are the properties of this particular molecule. If you want to paste it, simply click paste, then automatically the whole data will be transported from here to here. This is the whole data. Okay, so just like this, if you want a proton NMR spectra of this particular molecule, carbon 13 NMR spectra of this molecule, simply make it selected and go to view, structure, where at the bottom you will see predict proton NMR shifts. If you click that, then automatically proton NMR spectrum of this particular molecule comes over here with analysis. Okay, with analysis. Here you can see that it's a beautiful analysis. Okay, so that's how you can get it for proton NMR. And if you want to get a carbon 13 NMR, simply make it selected, go to structure and click predict carbon 13 NMR shifts, then automatically you'll get a carbon 13 NMR spectra. Okay, so that's how you can get the data of each and every molecule. Okay, this is what. And if you want to save this molecule, I have already told you, just manually also you can save, and you can just copy it and you can paste it in your Word or PPT. Otherwise, if you want to save the whole page as a picture like JPEG, you can save it. And once you save in JPEG, and at any place you want, any place that where you want to take it, and you can take it. That is not a problem. So this is what the second molecule. Second molecule also we have finished it. Now let us move on to the third molecule. Every molecule is a different kind of molecule. By drawing these kinds of molecules, you will get a little bit of practice. Let me go to the third molecule. Okay. So this is what the third molecule. Third molecule is a Fischer projections. This is going to be very easy. That is not a problem. Okay. All these things you can do it on your own. Okay. Let me copy this and let me open a new document. Let me paste it over here. Okay. I have pasted this one. Okay. Let me put it at on top, right top, so that we can draw it quite easily. So this is what the structure that we are going to draw it now. So how does it look? Just look at it. This is a straight chain, and then after that horizontal lines are also there. How do we do that? It's very simple. First you just take the single bond, because all are single bonds only. These letters you can type with the help of this text tool, and when it comes to single bonds and double bonds, you have to take the help of these single and double bonds of this main toolbar. Okay, let me just draw one single bond first of all. Okay, this is what one single bond. Okay, then after that I have drawn the second single bond also we need to draw. Okay, and then after that third single bond and fourth single bond. Okay, when you draw this, what happens? Okay, what happens I'll show you. Actually, if you want to just okay, chemical warnings. Okay, here you can see this bond. This is the first single bond. This is the second single bond. Okay, first single bond means there will be a carbon at the end, and there will be a carbon at the end. So once this valency is not satisfied, then automatically this red color symbols will appear. That means it shows that there are some more bonds that are to be added. Then only this red color symbol will go. This is what we call chemical errors. Anything errors are there, they'll be shown. If by default it is better for you to just keep it show chemical warnings. So what happens whenever you are while you are drawing, if any mistake is happening, definitely it will show with a red color. That is always better. So let me just draw another, because I need almost like 6 carbons. Now you can see this is one carbon, this is second carbon, this is third carbon, this is fourth carbon, this is fifth carbon, this is sixth carbon. Total 6 carbons must be present in this molecule. Now I got it. Now what I need to do is very simple. I will try to add these 2 bonds so that this red color mark will disappear. How do we do that? It's very simple. Select a single bond and click on one side and click on the other side. Then automatically it will go off. Okay, and on one side and on the other side. Okay, on one side, on the other side, just like that for every corner. If you do that, then automatically, okay, there will be no red color indication that is there, because we have satisfied 4 bonds of each and every carbon. Okay, now what you need to do, it's very simple. Simply you have to put these groups and atoms, how do we do that? Whenever we are going to type anything, we'll take the help of a text tool. We simply just select the text tool, and we will come over here where you want to type it, and there you simply click one click is sufficient. Then after that you type CHO. Okay, CHO. Okay, then after that at the right at the bottom, just select it, that is C2 CH2OH. Okay, so then after that here you have to just type OH. Here you have to type H. Okay, where you want to just type it, just go there and simply one click, then automatically you can type manually. Okay, so when you are typing is also, you have to be very careful. You have to make sure that you'll get a right atom is attached to the bond. Okay, this is how. So now you can see this is the molecule that we have drawn. Now you need numberings. Just like as usual process that we have done it. If you want to put the numberings, simply select the molecule. You just go to object properties. In that object properties, under drawing, you will have an option show atom numbers. You click that and you say okay, then automatically you will get all the numbers for every atom. And if you want to manually delete it, you can delete it. That's not a problem. Whatever the numberings that you want it, you can keep it, and rest of the numbers, you can delete it. That's not a problem. Okay, manually you can delete it. You don't want numbering to this. Okay, so this is the only numbering that you want it. Okay, now what you want, another thing is name. If you want to get the name, you simply select that, and you just go to this structure toolbar where you will see this option structure to name, and click that. Then automatically you will get a name of this particular molecule. This is an IUPAC name. Okay, generally in databases IUPAC names are preferred. That is the reason why you'll get an IUPAC name. Okay, if you want to attribute colors, I have already told you, simply select to what bond you want to attribute colors, or to what atom or group you want to attribute colors. Simply select that, and you go to color option on this general toolbar. Then you change the color. Okay, simply if you want to change the CHO, simply select that, go to general toolbar. If you want to make it bold, you just try to make it bold. Then after that you go to color. Then you want to this blue color, you simply click that, then automatically it will turn out to be blue color. Okay, that's how you can do this. Now after that, if you want to just move this molecule from one place to another place, you can move that molecule. Otherwise, if you want to increase the size and decrease the size also, by simply keeping your cursor at one of the corners, you can just increase or decrease. Okay, that is not a problem. Then after that, if you want to just have a chemical analysis data and chemical properties data, simply make it selected, go to view and show chemical analysis window, and this is what the chemical analysis. Simply do the paste, then automatically it get pasted. Okay, if you want to just chemical properties window, just go to chemical properties, select it, then paste it, and it will automatically appear over here. Just like that. If you really want to go to proton NMR, simply keep it selected and go to structure and go to predict proton NMR spectrum, then automatically you will get a proton NMR spectrum of this one. This is how, so beautifully. Okay, this is what a proton NMR. If you want to save it, you can save it, and otherwise if you want to copy the whole, you can copy it and you can paste it in any other platform. Okay, now we don't again if you want to just get a carbon and 13 NMR spectra, for example. So carbon 13 NMR, simply make it selected, go to object, view, structure, go to carbon 13 NMR, then automatically you will get carbon 13 NMR of it. Okay, this is what the carbon 13 NMR with the analysis. Okay, then simply if you want to just copy it, you can copy it. If you don't want it, just simply you can select. This is what the third molecule. Okay, this is what the third molecule. Okay, that's what we have drawn. Now let us move on to the fourth molecule. Okay, let us move on to the fourth molecule. So fourth molecule is a kind of a perspective kind of a model. Okay, let me just select this fourth molecule that we want to just do that. Okay, let me copy this. Let me copy this. Let me just take another page, a fresh page, where I want to just paste it. I'll paste this. So this structure 4 that we want to draw this. Okay, this structure 4. Okay, so how do we draw this? How do we draw this? It's very simple. Look at the molecule very carefully. Look at the molecule very carefully. It is almost looking like a first cyclohexane skeleton. Cyclohexane skeleton. Okay, with oxygen. Cyclohexane skeleton with oxygen at one of the corners. Then after that, there is a top and bottom. There are single bonds are there here, 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 and here. So basically, if we take a cyclohexane ring, then after that, if we type oxygen, then after that we'll put single bonds top and bottom. Then after that, we can put these groups with the help of text tool. With the help of text tool, let me do that. Let me do that for you. Simply go to this main toolbar. Here you will see cyclohexane ring. Cyclohexane ring. Click that cyclohexane ring and simply click on this white platform. Then automatically you will export that cyclohexane ring onto this. Now you can see this one here. So, but this is not the way it is. You need to rotate this. You need to rotate this. You need to rotate by 90 degrees. You can see this. This got rotated. If you compare these two, this one got rotated 90 degrees. So how do we do that? Can we do it manually? Yes, we can do it by simply selecting it. By simply selecting this lasso tool. You can use this lasso tool on this main toolbar. You just bring that lasso tool over here, then automatically you can see an arrow, a double-headed arrow, which is a rotatory arrow. Okay, that you can observe that, with which you can, if you want to rotate it, you can rotate the molecule. But when you are rotating exactly, you cannot rotate it. It's very difficult sometimes for you to just stop at exactly 90. Exactly stop at 90. Here you can see it becomes very difficult. But still you can you can move. You can rotate the molecule. To exactly rotate the molecule, what we need to do? It's very simple. Select the molecule. Select the molecule. Go to object. Go to object. Then at the bottom here you will see rotate. Here you will see rotate option. Simply click that, and how many degrees you want to rotate it, you simply type it over here. I want to rotate 90 degrees clockwise. Degrees clockwise or degrees counterclockwise. Counterclockwise. I want to rotate the molecule. Anyways, this is fine here. Let me rotate 90 degrees clockwise. If I click this option of rotation, then automatically it will get rotated 90 degrees. Here you can see this now. It got rotated. It is exactly looking almost like this. No, only the difference is in terms of size. The only difference is in terms of size. We can increase and decrease the size. You know that by simply increasing just like that. Not only the size, but it got little, change in the shape a little bit. How do we do that? It's very simple. If you want to change it, simply by using your mouse cursor, you can do it, and simply put it at this particular point. Simply drag this molecule. Okay, drag this molecule. Automatically, it has come into this kind of a shape. This kind of a shape. Now, what you need to do is simply you have to put oxygen over here. To put an oxygen over here, what you need to select? What you need? Which help? Whose help you need to take it? Simply text tool. Select the text tool and put it where you want to just type the letter. Simply click that and type O. Type O. Then automatically you have done putting oxygen at a right place. Now what you need to do, you have to put these single bonds in these places. Single bonds means that you simply go to the single bond and just simply select top. Okay, it's a little sometimes it's you have to adjust that line. Okay, top and bottom. Top, bottom, top, bottom, right? So that's how we have done it. Now what we need to do is simply you have to type these groups and atoms. How do we do that? It's very simple. Take the help of text tool and you put it over here where you want to just type it. That is CH2OH. Okay. Then after that, here you need to just type hydrogen. Here you need to type OH. Okay. Then after that, here again you have hydrogen. Here you have OH. Here you have OH. Here you have hydrogen. Here you have OH. Here you have a hydrogen. Okay, here you have a hydrogen. So that's how you can type manually. So now you have prepared this molecule almost, only this except this one. So here thick lines are appearing over here. This is what you need to attribute it. How do we do that? It's very simple. First of all, you select this line is a thick line. Okay, here you can select this one, bold bond. You simply select that. You come over here and put it on the bond. You simply select that automatically it turns out to be bold bond. But when it comes to here, this is a thick wedge kind of a bond. This is so go to thick wedge bond, simply select that, and you come over here and put your cursor on this particular bond, and you simply select it. Okay, in another direction if you want to select it, okay, this is how you can select it, and you just put it very close to this one and you can select it. Now you have prepared your molecule. Just have a look at this. Exactly, it's look like that. If you want to put the numbering, you know that how to put the numbering. Simply select this particular molecule, then after that, so you can, if you want to move it, you can move it. If you want to decrease the size, you can decrease the size. That's not a problem. Okay, then if you want to just give the numbering, simply go to objects and select object settings, and here you will have an option of show number, atomic numbers, and click that, then automatically you will get the numbers. Okay, now if you want, for example, the name of it, it's very simple. Keeping this selected, and just you go on the top, you simply select a structure to name, then automatically you will get the name. This is the name of it. So simply keeping this selected. If you want to just bring your chemical analysis and chemical properties, go to view menu and show chemical analysis and paste it. Okay, paste it. So then automatically you will get this data. Okay, here by keeping selected this molecule, you go to view and chemical properties window, then automatically you paste it. Okay, then you will get even chemical properties also, just like this. Okay, so if you want to move this data also, you can move it at any point of any place, you can just do that. Okay, so this is what the molecule. Now for this molecule, if you want to get a proton NMR, simply keep it selected, go to structure and proton NMR shifts, automatically you'll get a proton NMR spectrum of this molecule. Okay, and then if you want to, for example, for this molecule, carbon 13 NMR, select carbon 13 NMR, then automatically you will get carbon 13 NMR spectrum. Okay, so that's how you can get it for this molecule. So right now what I'm trying to show you throughout this lecture is how to draw the molecule, and how we can move the molecule from one place to another place, and how to increase the size of it and decrease the size of it, and how to just number the molecules, how to attribute colors to the molecules, and how to get chemical analysis and properties data, how to get proton NMR and carbon 13 NMR data, and how to just save the particular molecule, only that particular molecule, and how to export it to another documents. Otherwise, how to save the whole document as a JPEG image, and how to use that document, and these many things that you can do for one single structure. That's what I have been trying to show you. Okay, now it is already 4 o'clock and passed by 3 minutes. So I just there are 2 more examples are there. Those 2 more examples in the form of reading material I'll give you, and that is not a problem. I'll just give you in the form of steps also, step 1, step 2, step 3, steps, just like that, and you can practice those 2 structures. They are not going to be difficult. Actually, if possible, if there is a time in tomorrow or the day after tomorrow, quickly, if you want me to just show that how to draw the molecules of those 2 examples also, I will do it. But I should stick to the time. That is the reason why I'm just trying to wind up at this particular moment of it, and let us move on to the conclusion part of it, that is QA session. Let me just go through the chat box. There are plenty of doubts that have been asked. Actually, I have lost because of the power failure. Previous chat box I could not see. There were also some of the doubts are there, but there are a few doubts are there here. Let me just answer. Bhargav, sir, the numbering of the molecule, how to decide it, that from which molecule or which atom to start with? The numbering of the molecule, how to decide it, that from which molecule or which atom to start with? See, this is a automatically operated software. It will decide, it will give you the numbering. If you just do not for example, if that numbering that is given by if it is not you feel that the other way, if you want to give it, you can give it manually. That is not a problem. It will just take it automatically. It will take it and it will put the numbers. Okay. Sir, can you tell me how to copy the proton NMR data to MS Word. That is not a problem. You simply, for example, I'll show you. For example, for this molecule, proton NMR. Proton NMR, you want it. Simply go to structure. Okay, proton NMR, you get it. This is what the proton NMR. You try to save this document as the whole document as JPEG. Simply go to this top file menu and you simply say save as. Okay, save as. Then after that, on desktop, you try to save it as a proton NMR spectra. Okay, try to save this as a JPEG. Okay, JPEG, and try to save it. Okay, you say okay. Then I'll show you how. I'll show you how does it look like. So let me stop share and screen share again. So this is how it got saved. Here it got saved beautifully. Okay, this is a JPEG image that you have saved on your desktop. So once you save this as a JPEG image, then you can export it to any kind of place, right? Any kind of place, right? So that is what it is about. Then when writing CH2OH, by default, the 2 is it written down, or is there any setting for this? Yes, it is setting for this. I'll show you. So let me just take a ChemDraw. So here, okay, here by default, I have selected here in the general toolbar. Here you can see CH2 got selected here. So this is a formula toolbar. If it is selected, then automatically it will be typed properly. If it is not selected, for example, if I deselect that, then just look at it here. CH2 is it is typed normally, not as in the formula type. So always make sure that it is selected. So that it is selected. So then automatically it will be typed in a proper manner. It will type in a proper manner. So okay, that's okay. Sir, can you show again how to rotate the molecule? Rotating is very easy, Amma. It's not a problem. Okay, simply select the molecule. Select the molecule. If you want to rotate it, simply go to object. Here, number of ways you can rotate it. Like rotate 180 degrees horizontal, 180 degrees vertical, just like that. But manually, if you want any angle, if you want to rotate it, simply go to the option of rotation. Here you can put any angle, 1, 2, 3, 4, 5, just like that. Okay, you can put any number. Then you can choose clockwise or anti-clockwise. Then you can just click that rotate option, then automatically it gets rotated. It gets rotated. Okay, sir, can you change the dark line? Sir, can you change again how to? Can you change the dark line as different colors? Yes, any bond you can change the different colors. For example, let me show you. Okay, for example, you select the dark line. Sorry. So now it got selected. Okay, this dark line got selected. Let me go to the color. Let me put the red color. So just look at it now. It got turned into red color. So that is not a problem. It's easily you can do it. Okay, nice. Okay, facing some problems while logging into the software. Can you send us a first day recorded class? Actually, some of us not attended. So definitely today I got a message from some other people also. So definitely I'll just send the first day class for you. Probably that will help you. By tomorrow I'll try to do it. Okay, you just give it. Can we draw reactions like this? Yes. Tomorrow I am going to show you that the whole tomorrow is going to be our class of shortcuts class tomorrow. You see what we have done today is just manually everything, single bond, double bond, typing O and all of that. Repeatedly we are typing hydrogen, OH and all that. Tomorrow I am going to show you all the shortcuts so that you can draw the molecules very, very quickly. There only I'll show you how to, with one structure, how you can draw like a 10 steps, 20 steps, 30 steps of reactions within no time. Thank you, sir. Yesterday I was not able to draw the structure and give names, but today I got the idea. So how to select the structure? Selecting structure is very simple. You try to just go to these two tools that are present in the main toolbar. I told you yesterday only, lasso and marquee tools. These two tools, you can use it to select any kind of structure. Please explain how to draw horizontal lines in structures. Horizontal lines, in that Fisher projections, I did not do anything. Simply by clicking, you can draw horizontal lines. Horizontal lines. If you want to try, there is one tip that I want to just give you. For example, here, if you want to draw lines, simply just go to structure, object, simply deselect. Okay, this fixed length, deselect. If it is selected, you cannot draw at any length of a bond you cannot draw. If it is fixed, for example, fixed length, if you want to draw a line, you can draw this much only. If you try to drag also, you don't get it. It is fixed. Okay. For example, if you deselect that, and if you try to draw, you can draw the lines, horizontal lines like this, horizontal lines. Okay, just like this. Okay. So fixed lines is something is the key. Sir, how can we get examples for reference? So tomorrow I'm going to show you. Actually, today I wanted to show you, but the time is not there. Sir, how it is useful for students means in research and some other. Definitely. See, in research, you are going to publish the articles. Do you think, you simply write it with a pen on a paper and you will send it and people will accept it? No. You have to send these structures in a proper format on ChemDraw. Then only they will be printed. In a printed copy, all the chemical reactions you will see in the textbooks and research articles, there they are being made. They are being made on ChemDraw only. If you don't have a minimum knowledge of ChemDraw, you cannot make your molecules, not in a better fashion. So if you make it better, then if you send it and they'll accept it, they'll tell you, you have to send it in this format only, ChemDraw, so and so format. Okay. How to select structures from window? Which window we are talking about? This is a window option. So this window option is just I quickly I told you in the first day. So window option means, you can just keep just like in Photoshop we'll have different kinds of layers. Here also we can put a different kinds of windows at a time. We can work on 10 or 20 different windows at a time. You can just switch from one window to another window by simply using this window menu bar. Okay. Then after that, chemical properties convert to other colors. Is it possible? Acha, this one as a text, I think this is a very valid question that I did not try. Sorry. I think, if you select this, the whole individually you cannot do it. The whole things get selected. You go to the color and you attribute the colors to that. That is how you can do it. The whole things individually you cannot do it. Okay. I think that was the last question. And one more question, last question. Sir, if you take more time to class, take it, sir. No. It is not about one student. Naga Sweta is saying that, but it should not be like that. So there are so many students out there. Sir, I use Android mobile. I don't have desktop and laptop. How can I get good command on ChemDraw software? I just told you ChemDraw. See, some people have told me that ChemDraw is not like ChemDraw. Definitely it is not. So what did I tell you? ChemDraw will give you an idea. At least, so far only, people you have been working on Word and Excel and PowerPoint. Not like a ChemDraw kind of software, right? Since those people who are not being in a position to afford a laptop or desktop, I have given another option of ChemDraw where they can get a feeling of drawing chemical structures. If they get it later on in future, they might get a chance of laptop and desktop in institutions or in their places. So there they can get this, ChemDraw and they can do it. That's not a problem. So that is what the end of chat box. Over to HOD sir, Shukla sir.
Okay. On behalf of students, some of students, they are from MSc and BSc, and some faculty members are also present in the group. On behalf of all participants, I appreciate you, Busi Anil Kumar sir, for your efforts. And I am also enjoying the learning part. And I appreciate the participants because they are having a lot of patience and discipline. I request all the participants to mute themselves because there is some disturbance. If one will make the disturbance, then all the participants will get disturbed. Okay. Hopefully, I think you have enjoyed. Tomorrow you will have another great session. And thank you for participating. And tomorrow at 3 o'clock, we will meet again. Have a nice time. Take care. Be safe. Bye.
Thank you.